Hello, this is Bryan Sousa, and this is my demonstration of how I do the Xfoil project. So I already have it open. I'm gonna start demonstrating the Naka airfoils first because it's pretty easy. So I'm gonna go Naka 0015. So that's gonna make my airfoil pane PPAR, so I can get this. I'm gonna change N to 250, T to 1, enter twice. That looks right. Once again, now we go to Opera. We go to Visk, change it to 1,000,000. 6, perfect. Change it to 100 iterations. I'm gonna go PACC. That's a good name, Naka. 15. And now I'm gonna go SCPQ, QP, and then ASEC from negative 515.1. That should work. Now I'm just gonna pull up the text file because I want to make sure. Yep, looks pretty good. Cool. Start up Xfoil again and do the other airfoil. Naka 2415. Same thing, pane PPAR. Looks good. Oopsie. There you go. Okay. N250T is 1. Yep. Over this. 6. Iterations to 100. That. Naka 2415. SCQP. ASEC. Negative 515.1. Cool. Let me verify these results that it actually saved properly. Yep. There you go. So those are the results for the Naka airfoils. Now I already have the Clark one. Whoopsie. This is going to be annoying me now. There we go. Oh yeah, there's the Clark airfoil. I already set it up properly. So let's get out of this. Open it up again. Load the data foil. There it is. Oops. Pane. PPAR. N250. T is 1. Yep. Oper, Visk. 1, 2, 3, 4, 5, 6. Iterations to 100. That to Park W part 1. Because right now I'm just demonstrating part 1. And then we'll just go to the other parts from there. SCQP. ASEC. Yeah, I didn't forget anything. Negative 515.1. And that should give me the results for the Clark airfoil. Let's see here. Yeah, there they are. Okay. And yep, those are some good results. Cool, so that's part 1 really quickly demonstrated. So for the other 2 parts, I could repeat the initial Clark airfoil, but it shouldn't be necessary, and I'll explain why later. So let's go back, airfoil, and now I'm going to do part 2, which is where you take the Clark W airfoil and just change the viscosity. Let's load again. The Clark. And then do the same thing. You go pane, PPAR. N is 250, T is 1. Don't change anything else. Upper. Leave it viscous. Or inviscid, sorry. At least for the first one. Clark W, inv. That's fine. That, ASEC. Okay. And that should be it for the inviscid flow. Yeah. Yeah, and CD should be 0 here, so we're good. Now I'm going to do it for the laminar flow. Ooh. Now we go to Visk, but now, ooh. So, sorry about that cut. I just had to open up the project to make sure that I can verify the Reynolds number here, which is going to be 3, 1, 2, 3, 4, 5, I believe. 1, 2, 3, 4, 5. Yep. Okay, so that is our Reynolds number. Iterations should still be 100. Yeah, that's good. Okay. So that's how you do the laminar flow, and I'll just show that it saved properly. There we go, all the values are there. Now this is what I was talking about earlier, where for the turbulent flow, I'll just show it, but it's going to be the same thing as for part 1. You load or w.dat, because it's going to be the same exact conditions as before, but since I have to show all parts, I'll just show this here. 1, 2, 3, 6, 100. Disk. Sure. There we are. So that'll get the turbulent. Oh, I named it viscous by accident. That's the results, which is going to be the same as before with the part 1, but I just want to make sure that everything is okay here. So yeah, that's how you do part 2 with the inviscid, laminar, and viscous. So I'm just going to really quickly go over the flaps. Okay, so what I'm going to do is I'm going to go pane, I'm going to gdest now for a flap. I'm going to go 0.7, that's what I did with the project, that's what was shown in the tutorial. Y at 0.5, I want it to be, I'm going to do 10 degrees first, EXEC, that should do it. And now I go PPAR, and now I want to go N is 250, T is 1, don't change anything else, I want to change this to 1 million, I want 100 iterations, and W, just put 10 for 10 degrees, simple. Now I just go SCQP, ASEC, negative 515.1, and we wait. Okay, let me show that the results are there. Here they are. So that's how you get results for the airfoil with the 10 degree flap. Let's go back and do it for the 20 degree. 0.7 again, I want to put it 0.5, now it's 20, EXEC, and now I'm going to go PPAR. This one I changed. I had to go 350 for the N here, just to make it converge. Otherwise it just doesn't work. Visc, change it 6. Now I need to go iter. I used 1,000 iterations. This just helped make it work. W20. Okay, now I go SCQP, ASEC, T1. There you go. Okay. This is going to take a while, so if I cut here, that's why. Alrighty, we're back. The calculations are done. Allow me to show that we get data. Yeah, for some reason, I have trouble getting -5 here. With a little more fiddling, I could make it all work. But, this is essentially the process. It's just sometimes I don't... It's either -5 I don't get, or 11 degrees that I don't get. And it's very strange why that happens. But I managed to get a full data set and include that in my project. And so what I'll do right now, just really quickly, I'll review how I just put everything on the tables. So this is my Excel spreadsheet that has all of my data that I collected across all the parts. And I mean, the way they open it, I'll just show for one of them, just so I can show that, yes, I know how to open these files. If you go to all files, you go to, I need to find my Xfoil, there it is. Xfoil, and then I go, I don't know, this one, the knockout one. This is fine. You go next, next, finish. And then there's all the data that I collected from the earlier demonstration. And it's literally the same process for all of them, so I'm not going to be copying the same thing over and over again when it's no different. So let's close this out. I don't need it. I have all my data here. You can see that I constructed some of the graphs. But what I did is I took all of the different data points, put them all into a singular table like this, so I can graph them all on the same plots. Yeah, so I have all the plots for part 1, all the data and plots for part 2. Oops, I'm scrolling down. And then part 3 is the same thing. And it's Excel, it's very easy. You just do this, insert a chart, and then this one. And then there you go. And then I changed the axes, I made the colors look nicer, and that's it. So really that's the whole project, how I got all of the values and how I stuck it all into Excel and made the graphs. So yeah, thanks for watching.